Hey there, it is me. I have to stop for a while. The feature drive is strong in this one, very strong. It is very difficult to stop adding more. But I want to show you that thing that I said I was going to do, and I did it. Let's get rid of this here. Now, one of the things I figured out how to do is the full screen thing, but it will take some work. Now I'm going to get into this mode. Now, one of the things I can do now, I go here, let's put labels. Oh no, why is that white? Hang on a sec. It's supposed to be red. No, how come it's not red? Just a minute. Okay, sorry. My fault. I forgot how my program works. I forgot to do lerp. So run this. Get rid of that. In the vector mode, I can draw vectors, but what I want is the lerp mode, which looks like this. And I can plot a point. And one of the new things I just added was being able to put labels. So these are the A, B, let's say, go that at the end here. C, and we'll say D is here. C and D. Okay, now the first time it's going to go through 0.5 quicker than before. Okay, so this is the DeCasteljau algorithm of subdivision, linear interpolation. The next step is these two lines, even though they look parallel, it's two different lines, will be divided, well, linearly interpolated by this amount, which gives rise to two new points. And once we're down to 2 points, there's only one more line left to draw, and that's the white, which we interpolate to get a white dot. Now, at this point, it goes into automatic mode. It's just going to randomly select a floating point number between 0 and 1, and do the whole thing slowly, one at a time, leaving only the white dots. So you can just watch along with me. You can see the amount in the corner here. It's indicated. So we have 3, now we're making our 4th dot. Now if that's too fast, I can slow it down. So we have a few lines, a few dots, And you can see it's almost forming a shape. This is at 750 milliseconds pause between each action. Before I had it at 5 seconds, and it's quite slow to watch. So now you'll notice that it's not just looking like a bunch of random dots anymore. Those dots are certainly following a line of some sort. I don't know, oh, that last one went here. We got one near this is on the graph, this is just a part of the tangent. Now 0.35, we need more bigger values. I think because of the length of this tangent, there aren't many numbers that'll wind us up in here. 9.2, that might get in there. Oh yeah, that gets in there. So 0.9-ish. The thing that's not linear about this process is the probability of a particular dot being drawn as a function of its position on the curve. These are less likely, obviously. There's a lot of holes, and these middle ones are more likely. So if you used t, if you turned this into a parametric function and let t be this t, then you won't get constant velocity motion. Now it's definitely looking like a Bezier curve. Now I can slow this down actually. No, I don't know. No. Okay. It's just with my timer thing. You can see how quickly I just put this if down. I flipped the demo flag as soon as I hit the last stage. Didn't make it not demo anymore. 750 is what I brought it at. Well, actually, let's try slowing it down instead of speeding it up. Let's 2 seconds so you can see it happening more slowly at first. Then what I can do is speed it up really fast and see, we'll see the curve forming much more quickly. More action too. I didn't add a color for my labels. I just decided red. I should get rid of those lines. Now where do we want to go? A. How about we let A and B be pretty close together? Let's see what effect that has. And same with the other two, but I'll put them here. See, and how about like this? Okay. So it's supposedly it's going to go like that. In 2 seconds. Oh, I only changed one of them to 2 seconds. So I gotta go and fix this. This is the one I changed it to. They're all. It's not a parameter thing. I don't know. Let's do it again. I'll make this a parameter. Alert demo text. No, demo text. And on entry, or actually, I have to set them every time because I clear them out of inventory. Now, if stage is 0, this I would actually I can change this slightly. I can make this random. How about this? 600 to 4. How about 400 to 700. 1. No, that would go to 1,000. So that'll be like from 0.4 to 0.7 for the initial value. It only goes to stage 0 once, never again. And now I just gotta change all these timer things. And work demo tip. I know I missed one. The one I already changed. Well, it works out to the same thing. So for those of you who didn't watch the last one, what I'm demonstrating here is one method of calculating a what they call a Bezier curve. Now there are various types; they have different orders. Okay, but the method of drawing and creating the curves is exactly the same. All you do is add more control points. What the control points mean doesn't matter really. You just place them wherever you want and see what the effect is. And if you get a nice curve out of it, then you're happy. But you could study it and get a better feel for what they are. In this case, in the cubic case, they have an obvious meaning. they're just the tangents, right? I mean, there's 2 points that are on the curve. Not this one. This first point is a point extended from the tangent of one of the points that's on the curve. Like here, let's say. Right? So this here, B, is on the curve, and this is a tangent line. Now the curve goes from B to something called D, which might be, let's say, here. So it goes from B to D, and if suppose at D it's tangent in this direction. So we could draw, we could take this as one of the tangent points. I mean, a part of the tangent line, and then this is the end of the curve. Okay, well, we got 5, 4. So it seems like we got more green dots than we. Oh no, these shouldn't be. It's okay. Okay, so now it's going to do the final one, and the final result of that operation was that one point there. Now it'll just keep going, doing the same thing, but automatically. 9, 7 is a very high value, so it should be close to the D point. Back, you can see where it is. It's right beside D. 9, 7 again. Very unlikely, but it does happen. 0.06. So you see how it works. We find 3 points by not bisecting, but linearly interpolating by some random amount between the number of, it's always one less than the number of lines. And that's why this algorithm terminates, because if you start out with 4 lines, that becomes 3, and then 2, and then 1, and then you gotta start over again. So now in this case, it's a much more flatter curve. Now I can sort of guess what it's going to look like. No, wait a minute now. No, A is on the curve, not B. B is a tangent and C is a tangent, not A. A and D are the endpoints of the curve. Sorry about that. Now I know how to, I figured out how to do full screen, but you remember this? I don't know, you don't know, you probably don't know this, but I found out, much to my surprise, by looking it up, and somebody said, I don't know, you see this thing, Notepad-like program. When you change from word wrap on and off, either in Notepad or in this program, it destroys the only way to do it is it has to destroy the entire window, internal window, and then rebuild it rebuild it again. And that's exactly what I have to do with this program. If I want to go to full screen mode, I have to destroy the entire window, create a whole new window of a different sort, and just maintain the data and rebuild the data in the new window. That's not very hard in this case because I have it all in a memory device context, which is 800 by 600, right? That's not going to change size no matter what I do with the window itself. So I've got this image is in memory. All I got to do is figure out how to, transform it from memory onto the new display context. Now, there's nothing hard about that. Stretch-split works. The only slight difficulty might be in the way that I invalidate the rectangles. I try to find out which part to erase and where to not erase, right? So I need a transformation from, if I say invalidate this rect, I have to transform that as well into the other context. But that's no problem either. That's just a matter of rescaling and moving. It's just a rescale. Alright, so now you've seen that happen. Now I'm going to make it go real fast and set the one of those values anyway to like non-demo to 200. I'll set this to 1000. Be slow for the first run around, and then it's just going to zip along, and we should see the curve form pretty quick. Then I'm going to try and do the full screen thing, and once I have that done, I can show you how these permit things work. Why don't I get rid of those? I won't bother with the labels. How do we want to go? Let's see. This will probably make it very skewed. That's pretty cool, really. I'd like to see this in full screen mode. It's got a very a very earthy feel to it rather than those animated GIF things, like it's like AutoCAD or something. Well, listen to me, that's earthy. That's hippie stuff. Well, it's already, pretty much the curve is already evident, right? If you drew straight lines through those points, you wouldn't see any jitters. A little bit here, maybe. That's a slight bug that I shall fix. That comes up over and over again. It's because I'm doing everything manually and I'm being very careful. Well, it's pretty much full. Let me try another one. I don't know if I can. I don't think so. No. It's not that good. It's not that well cleaned up. I just happened to get it going, and yeah. Well, we go this way. Start here. Actually, one thing I'm curious about. Usually I go here and then here, but I could go. This is still a tangent, right? So it should come out this way. It should start from here, and this is the end point, and it should be parallel to this line coming out this way, like a turnaround. This should be like exactly a turnaround. And in fact, look at it. It's exactly what it's doing. So we get the wiggly ones if we're going out the same way that we came in, and we get to have like a semicircle if we change directions. What's another possibility? We can go in the same direction, we can go the opposite direction. Well, I can't think of anything else. Well, it could come back towards itself. See what that does. Now, then what I should do really is add add some more control points. But it can still be done, I think. If we start with a vector, that's a point on the line, point on curve. Now I'd like it to be coming back towards itself. So here and then here. It's not exactly towards itself, but it's close. I should have made it bigger. That's quite interesting, actually. You can make it come back. I really want it to go right directly back at itself. Okay. Tangent this way. Now if I move here, I have to go that way. Well, just parallel to this, right? So here and is that about parallel? No, more like that. Go. I made one longer and one shorter to see if that affects and it does seem to affect the slopiness at the line. Well, I don't know. Seems like there's an asymmetry here. This will go nice and smoothly this way. Why does it have to do the turnaround here? Because I didn't pull this down far enough, I see. If I'd made this exactly the same length, I would assume it would. Oh no, it's not symmetric. This is a very small angle, and this is obtuse, and this is acute. Well, there you go. That's fun and games, and that's pretty much the simplest type of curve element in computer graphics. These are elements. The things that I'm going to get to, splines, are like they sound, like the splicing together of various elements to make a complete curve of an arbitrary shape, and that's nice and smooth. And it turns out that it's not very difficult to do at all. You saw how easy this algorithm is. There's nothing to it. There's all that theory is useless. I could add a 4.1 and see how that affects it, but it's just like maybe adding, right, every second. If you add more and more control points, well, I'm not sure. I thought maybe it would connect one of these with another one and so on, but I'm not sure. Okay, see ya.